This is an introduction to the Orland framework and Flex Builder. We'll start by creating a new Flex project, then adding an application. You can see both the code view and the design view. To this we'll add a label, and we'll center the label. We're using constraint-based layout, and we're centering the center of the label to the center of the application frame. We'll set the label color, then the font size, then the font weight. We'll then set the application background color, you can see both the updates in the code and in the design. Then we'll preview this in the Orland viewer. The output should be the same. We'll then try that in the Adobe Air viewer, and again the output should be the same. We'll then convert the file to the binary format used by the phones and preview this in a series of handsets. First up is the BlackBerry Torch. The viewer is built using OpenVG. Then the Sony Ericsson iKnow. This is a J2ME version with a software renderer. Then the G1, using an OpenGL renderer. Then the Nexus 1, using an Android canvas. Next we'll try an introduction to lists. Create a new application as before. This time we'll only use the code editor. Add a new list component, setting the width and height to the remainder of the screen. We then give the list a label. If you look at the design view, you'll see an empty list and our label. Next, we'll give the list some content. Now we have a list with content, and we'll preview this in the Adobe Air viewer. And then in the Orland viewer. Notice the addition of flick scrolling. We'll then perform the conversion, as per earlier, and try this in our handsets. Notice the look is exactly the same from handset to handset. The fonts are the same, the UI components are the same. This time, we'll create a list as before, only now we'll use a component as the item renderer. Instead of drawing a single text line, we can have a custom component however we like. We'll add an image and a label. In order for the list to use the item renderer, we need to expose its data property. Again, we'll preview this in the design view. Next, we'll create our application. We add a label, as before. Then the list. We give the list an ID, which we'll access from script, and then tell it which item renderer to use. Then we add some script, which connects to Flickr and queries for pictures of cats. We test this in the Olin viewer. And then we convert for phones. The current implementation doesn't support image caching. This will be added at a later date. For the final introduction, we'll move to Adobe Director. We create a new movie and we add a label. This time we're going to write a test for the accelerometer, accessing the hardware in script across all platforms. Because we're in Director, we can add animation. So we'll add a simple slide of our text. We create our keyframes at the start and the end, and set the positions of our animation. Director will then tween between the two. can alter the tweening properties, and test. Next we'll add script. Here's something I prepared earlier. The script reads the accelerometer values and adjusts the position of the sprite accordingly. We'll add a second script that runs when the movie starts and stops to enable and disable the accelerometer. This allows us to conserve battery. We'll add an image, and this is the sprite the accelerometer values will affect. The director itself doesn't support the accelerometer, so we need to export this and test this on the handsets. The export tool is part of the Olin toolchain, and we can view the resulting file in the desktop viewer, again without access to the accelerometer. Each of the Olin ports exposes the accelerometer in the same way, with the same range and the same values. So one single file runs on all versions of Olin. Using the same techniques as the previous simple examples, this audio player combines lists, internet connectivity for the streaming audio, and hardware access to play back the audio.